say that, let's see, next on deck, Ryan's not in this room. Travis is not in this room.
Okay.
So I see your OBS. All right.
Okay. Um, all right. This is my optimization improvement document. Um, I didn't make it as the PDF yet. But I would do it later when I
Great.
submit it. All right. The basic concern is the optimization performance is one of the extremely game topics. There is no one-step solution, and sometimes this method works for you, but it doesn't mean that works for everybody. And what I'm going to talk about in this document is the definition and identification for areas at causing drops and performance. Also, a series of techniques that can be used to improve performance. Alright, as you can see, the CPU basically control it updates game state by checking player input, calculating collisions, fixes, and more and more. And then next steps is after the calculations done, it tells what needs to be drawn and send the instruction to the GPU, which is the graphic processing unit. And then the GPU takes to the next step and shows the information and then the image to the screen. Um, uh, what I talk about a little bit more between the CPU and GPU is basically just talk about what is their jobs and what actually they handles in the processing, such as the what is handled, and then when it is important to identify where your game is losing performance, because it is pointless applying techniques that aim GPU when it's actually the CPU is causing issues. So when the CPU is causing issues, we call it CPU bound, and if the GPU is causing issues, we call it GPU bound. So how do we know what is causing the loss of in performance? We can bring up the profile in Unity. This is the its own tool in its system. By collect the window and go to analyze and then performance. Here's the how the portfolio looks like. It has the CPU usage and then GPU usage. You can compare the FPS by looking at the portfolio and determine which area is causing issues. The highest time in the case of that unit is um, bottleneck for the specific volume. Alternatively, to say about performance issues or GPU, um, and this is talk about the performance issues which is related to GPU. And next, let's talk about some techniques to improve the performance. First, what is the draw call? To draw a game object on the screen, and the engine has to issue a draw call to the graphic API when rendering your game object. Changing material and texture property is relatively expensive. operation for the graphics card. We can do the draft batching. What does that mean? It's group some game object in the scenes together that share the same material, which is allow multiple game object to be processed within the same draw call. The few draw calls we have the better performance if you have. What does that means is just like this image shows to combine multiple material into one material. And then the next is the dynamic batching. This is handled automatically by Unity for game object within a certain vertex count. Also, the static batching will occupy some memory storage. And then the shadows and the what is that? Per pixel lights and then the reflections. These three elements close game object to be rendered multiple times, so it is possible to reduce the use of them. The shadow distance can be set in the project setting. Just go to the edit project setting and you will get these windows. You can set the number and then the. Can you guys see or I need to zoom in?
Yeah, please zoom in.
Oh yeah. Is it better?
Mm-hmm.
Okay. And then the next is the per pixel light. It calculates the lighting for every screen pixel, which allows for realistic lighting. You can go to the edit and project setting. This is the pixel light count. You can improve your optimization by setting up the number of the pixel light count.
So increasing or decreasing that?
I think is decreased.
Mm.
Yeah. And this is how the difference between the pixel light and then the vertex light.
Yeah, pixel light looks a lot less efficient.
Yes.
Mm-hmm.
And the last is the next is refraction. It has many parameters that can be used in end performance, such as its solution of the area of the effect. This is the after the reflection setting up. This is how it looks like. It looks so real, and this is the setting before. You can compare the difference between the reflection and by setting up just adding that reflection probe and then change the resolution and then the shadow distance. For this one it has only 16 and this one has 1024. The next method is optimize model geometry. Basically just avoid using any more triangles than necessary if there is a sort of your model that invisible. What does that mean is I can show you. So for this is a game object. If you see on the top, so the bottom face is useless. So it need to be delete the face. Yeah. just use less face. Just delete the face that you won't need it when you building the model. And next is the lighting. Light mask is the most efficient way to optimize lighting, which means that once the light map is generated, the lighting no longer needed to be computed in game. So what does that mean? Just basically reducing some light in the game setting. The last method is the texture. Compressing texture will improve load time. Also, it has the smaller memory footprint, which will aim at you reducing garbage collection issues. I think, yeah, I think that's all I have. Thank you for watching.
Thank you. I